told you, we are going to learn how to go from vertex form to standard form, okay? Because we want to be able to go from one form to the other. So what we're going to learn in this unit, part of what we're going to learn in this unit is to go from the vertex form, which is y equal ax minus h squared plus k, to standard form. Which is the expanded. Okay? So we're going to learn how we can convert from vertex to standard form, and we're going to talk about what we call this process. Okay? Now, why do we want the different forms? What is important? Why do we care about the different forms?
I'm guessing in standard form is the two forms that meet two zeros.
Actually, it's not the standard form that gives you the two zeros. It's the factored form. Okay? But we need the standard form to be able to go to the factored form. There's no straight way to go from a vertex to factored right away. Okay? There's no like one way, okay, or whatever. It's not direct track. Okay? I have to do a layover in the standard form in order for me to go to the factor. Okay? So that's why I need to be able to go from vertex to standard, so I can later go from standard to factored. Okay? That's one reason. What can I know from the vertex form? Vertex form is probably the most important form because it gives you a lot of information. Once you know your vertex, you're set. You can graph, okay? And you can get all other information. But then sometimes we don't want to graph, right? It's probably easier for us to convert from vertex to standard by just doing algebra instead of graphing. Who likes graphing? Nobody, right? So it's probably easier to do algebra to go from here to here, okay? Now, I want you to look at these two graphs. What can you tell me about these two graphs, just by looking at them? They're the same?
Yes.
Okay. How about the equation that represents each graph?
Different.
They're different. What's the difference between them? So the first one, what form is it written in? The vertex form, right? How the second one is written in? Standard. Okay, so if I put this in Desmos, it's going to give me this graph. If I put this in Desmos, it's going to give me this graph, which is exactly the same graph, right? It's just except one is written in vertex form, the other one is written in standard form. Okay. Now, if I'm looking at the vertex form from the equation, what do I know right away? The vertex, which is what? 2 and 1. It's not negative. Remember, the vertex is 2, 1. Okay? So the vertex is 2, 1. What other than the vertex would I know? Like the y-intercept from this form? Can I find the y-intercept from this form right away? But when looking at the graph, I can. Yeah. Now from this equation, the vertex equation, what else do I know? Optimal value, which is a min at y equals 1. I know my axis of symmetry, which is x equals 2. I know the direction of opening. Which way does it open? Up, because the a value is positive, right? I know my step pattern, which is 1, 3, 5, right? Because my a value is 1. So I know all of this information from the vertex form. Now, if I'm looking at the standard form and I'm looking at my graph, what information from the graph matches the information in the standard form without doing any math? The y-intercept. So what's my y-intercept here? 5. And what part of the axis of the equation does it match? The plus 5. So it's the last number, right? So if I'm looking at my standard form, it matches the C. And that's always going to be the case. The standard form will give you your y-intercept right away without doing any math. By looking at it, you know where your y-intercept is. Okay? Anything else that you can know from the standard form? No. Well, yeah, sure. I know it's going to open up because my A, again, this A, and this A, where is it? They're going to match. Okay. Oops. Let me do this. So this A, and this A, they're going to be the same in all the three different forms. Okay? So, looking at the A here, it's a 1. So I know it's going to open up. I know that it is going to, I can, not in a second. Step pattern is only for vertex. So, there's not a lot of information that the standard form tells me. It only shows me the y-intercept. Okay? Now, but as I said, we're going to use it as a stepping stone. What did I just do? We're going to use it as a stepping stone to the factored form. Now, we will not learn how to go from standard to vertex, but there is a way to go from standard to vertex. They only learn that in the mixed level and in the U level. If you are interested and you would like to know it, you can come and see me and we'll go. It's not an easy process though, just so you know. So, what information about the key feature of the parabola can you take from each form? An equation in standard form, which is y equals ax squared plus x plus c, tells the location of the equation of the y-intercept. And remember that your y-intercept is your c value. An equation in vertex form. What's the vertex form? Y equals? What does it tell me? The location of the vertex. What else? Axis of symmetry and the optimal value, which is, they all can be found from the vertex, right? Are we okay with this so far? All right. Now, how can I go from, algebraically, how can I go from the vertex form to the standard? Okay? So if you look at the vertex form, what do you see? If I just hide that +1, what do you see?
Squared.
A square, right? What did we do in the previous lesson when we had a square?
It's still the same. Keep it the same.
Write it twice, right? Write it twice. So if I want to expand, I can write this twice, multiply, and then add 1. Okay? Because BEDMAS says deal with the square or the brackets first, right? So the process called expanding, okay? The process that we did earlier, it's called expanding. Yes, we use the term FOIL just to add the acronym for first, inner, outer, last, but the process is called expanding. Okay? So to go from vertex to standard, we can do what we call expand by expanding. Expanding. So to expand, the first thing that I'm going to do, I'm going to write my x minus 2 twice because it's squared. right? I still have the plus 1 outside. I will deal with that later, okay? The last thing I do is I act. Are we okay with this so far?
So when it's two brackets next to each other is multiple?
That's right. Now, what do I do when I have two brackets multiplied by each other? What do I have to do? 4. So x times x gives me x times negative 2. Negative 2 times x. Negative 2 times negative 2. And then I have that positive 1 that's coming out down from the vertex. And my last step is to collect like terms. Okay? Collecting like terms. What are like terms here? So x squared stays the same. So these are my like terms, and that gives me negative 4x because they're both x's. Plus 5. And these are my like terms, so I'm going to add them together, and that is my standard form. Right? So if I go back here, right? Yeah? That's what I just got. X squared minus 4x plus 5.
So you take the point of the and a value.
No, you're going to write this twice and then 4.
Yeah,
Okay? Now, in this case, I did not have a value of a outside, okay? But if I had a value of a outside, like the next question, okay, it's going to be a little bit more work. Okay? Let's look at the next question together. I'll give you time to work on the homework, so I can focus on the lesson right now. Okay? Given the equation for a quadratic in vertex form, so this is the equation, the question says, state the key feature you can determine from the vertex form, expand the equation to put it into standard form, then state the key features you can determine from the standard form. So I have 3 things that I need to do. So I'm going to write the question here again, y equal negative 3x plus 1 squared and minus 4. Okay, what can you tell me from the vertex form? What's the key feature? What's the vertex? What's the vertex? Negative 1 and negative 4. I can tell what my axis of symmetry is. What is my axis of symmetry? X equals negative 1. Optimal value? Y equals negative 4. Guys, why am I taking the time to say it and to write it? Because this is the expectation, right? You need to note it properly. Now, can you tell me if it's a max or a min? It's a max. Which way is it going to open?
Downwards.
It's going to open down. So I have a max. Okay? So I know the vertex, I know the axis of symmetry, and I know the optimal value, and I know it's a max. So I stated all the key features that I know. Now I have to expand. So to expand this, what do I do? Brackets first. So write the bracket twice, okay? Because it's x plus 1 squared. So I'm going to have to write that twice. Then do the brackets forward. So eyes on me for a second. You see in this case I have a negative 3 outside. I am not going to touch that negative 3. I'm going to leave it outside for now. I'm going to FOIL then I will deal with it after. Okay? So write the negative 3, FOIL your x plus 1, x squared plus x plus x plus 1 yeah. Now after I expand it, now I can distribute that negative 3 into the bracket. Okay? So now we're going to multiply that negative 3 into the bracket. Okay? So that gives me negative 3x squared minus 3x minus 3x minus 3, and then take away 4. So I multiply the negative 3 into each term inside the brackets. And what would be my last step, guys? Collect like terms, and what would be my like terms? Negative 3x squared.
Negative 6x.
Perfect. Excellent. Right? My like terms are the terms that have the same letter and the same exponent. Are we okay with that? Questions? Yeah.
Will it be different if you simplify the x squared plus x plus 1 then you distribute
No.
after?
Nope.
It's going to
It will be the same. Yep. But then that's an extra step, which is fine. You can do that. That's totally fine. Are we okay with that? So the question was, would it be any different if I actually simplify inside the bracket first, then I distribute, so I add my like term and then distribute? It's going to be exactly the same answer. It's just an extra step that you're going to have.
What if one of the 3 was a positive 3 and it was a negative?
Then they cancel each other and then become 0.
Okay, so I don't have to put the
No,
x.
then you would leave that. So the question is, what if this was negative 3x and plus 3x? Then they're going to cancel each other. Plus and minus 3, they're going to cancel each other. Then you won't have the x term. So you're going to end up something like this. You'll have questions like that in the homework. I know. All right. Now, what can we tell from the vertex form, guys? Sorry, from the standard form. So y-intercept is at y equal negative 7. Any other information I know? No. That's it. Okay? So, in a case of you have a word problem, and it gives you the vertex form, okay, and it asks you what is your y-intercept, one way you can do is you can put it in standard form and then say the y-intercept is at this. Okay? So if I give you this, right, and I ask you in the question, what is your y-intercept, right? One way to do this would be to put it in standard form and state the y-intercept. Okay? Or you can plug 0 for x and find it. That's another way. But we'll talk about this more when we get to the word problems. Any questions before I let you work on the questions at the bottom? Any questions? All right, so you're going to work on these 3 questions. What is it when I have a negative here outside? What does that mean?
-1.
It's a -1. Okay? All right.